p55 Lewis dot diagrams. So these are simple illustrations that Lewis, who was a chemist, came up with to help us understand and figure out how atoms might bond to form larger molecules, particles, and compounds. So remember, electrons can be transferred or shared in order to form bonds. So in the Lewis dot diagrams, the element symbol is used to represent the atom's kernel. The dots in the diagram are used to represent the atom's valence electrons. Any dot diagram, it can have only a maximum of 8 valence electrons. The pattern in which we place the electrons around. So typically in a traditional form, the 12 o'clock position, so think about the element symbol as a clock, 12, 3, 6, 9, at the 12 o'clock position, valence electron 1, and then valence electron 2. 2 electrons max on a side. There's a third valence electron, we place that at 3 o'clock. The fourth valence electron would be placed at 6 o'clock, and a fifth valence electron would be placed at 9 o'clock. Now we can have up to 8, so there's 3 more. If there's a 6th valence electron, we would place that at 3 o'clock. A 7th valence electron would fill in the leftover space at 6 o'clock, and if there's an 8th valence electron, we would place that in the remaining spot at the 9 o'clock position. And as you can see, the positions, there is a max of 2 electrons per side of the symbol. So let's use these ideas and look at a couple of examples of Lewis dot diagrams on page 56. So we're taking a look at the element beryllium. And so when you go and look on your periodic table, beryllium has an electron configuration of 2-2. So remember, the first number in the configuration is energy level 1, just closest to the nucleus. So energy level 2 for beryllium is the valence. It's the last number in the configuration, so that's your valence electrons. Beryllium symbol is Be, and we get to place 2 dots around it. So the first dot, electron 1, and then electron 2. That's all beryllium has. Now if we move on to phosphorus, and you find that on your periodic table, its configuration is 2-8-5. So the 5 being the last digit in its electron configuration, that represents the number of valence electrons. When you look at the periodic table, phosphorus's element symbol is P, and now we place the 5 dots around it. So for phosphorus, electron 1, electron 2, electron 3, electron 4, electron 5. So it looks like this pattern for the dot diagram. Our last example, acetine, and it has a pretty long configuration. So it goes 2-8-18-32-8-7. Acetine has electrons in energy level 1, 2, 3, 4, 5, and 6. So it has a lot of electrons in its entire structure. So acetine, the last digit in its configuration is a 7, so that means that's the number of valence electrons. That's the number of dots we put around its symbol. And when you look up acetine's periodic symbol, it's not A and it's not AS, so make sure you look these up. Acetine's symbol is AT. So let's start working with our pattern of the dots. Out of the 7, electron 1, electron 2, electron 3, electron 4, electron 5. And now that I have at least one electron, now I go back and pair up. So now back at 3 o'clock for electron 6, and then at the 6 o'clock position for valence electron 7. So this is what AT's dot diagram looks like when it has 7 valence electrons. Try the practice questions below. Check your answers with your teacher.